Assalamu alaikum dear students. Students, we are starting with the revision and we are starting with the revision from chapter number 1. So in today's video, I will be covering some topics over there of your chapter number 1 which we have already seen. Okay. Solid state. You know the definition. We have discussed the substance having definite shape, mass and volume is called solid state, and we are having certain characteristics and which you are able to see it over here. That is fixed shapes, atoms are closely packed, rigidity, IMF and IMS, intermolecular forces and intermolecular spaces. Okay. Next topic on the basis of CP. What is CP? Constituent particles. We can say the solids are classified into two parts, that is crystalline and amorphous. So crystallines are having the particular points that they are having the three-dimensional structures, wherein amorphous the particles are haphazardly arranged. Sharp melting point, do not show sharp melting point. Anisotropic and isotropic. So we are going to talk about the this particular property. It undergoes a clean cleavage, and the solids on the cleavage form this more smaller particles over there with the non-planar faces. Okay. Now we are going to discuss about the definition of your anisotropic. Because of the arrangement of the particle differ in a different direction, the properties are differing. So different directions, when you observe, the different properties are observed. That is known as your anisotropic. Okay. Next, uses of the amorphous solid. We are knowing it is used in inorganic glasses, in the converting of the sunlight. That is your photovoltaic cells, rubber and plastics. So these are your uses, or you can say applications of your amorphous solid. Very important, pseudo solids, which are also called supercool liquids. So we talked about this, that they, like a liquid, has a tendency to flow, not very rapidly but very slow. Okay, so they are called pseudo solids, or we can say supercool liquids. I told you, if the example is asked, you can go for writing the glass panes of the old buildings are thicker at the end. So that is example. Okay. Next, the classification is your crystalline solids. So crystalline solids and are distributed depending on the constituent particles and the force of attraction. So molecular solids is the first classification. They are having constituent particles as a molecule, non-polar, polar and hydrogen bond. Okay, you are able to see also which kind of the forces are present over there. That is what we talked about. Next, we talked about the covalent solids. So dear student, in covalent solid, we talk about the isotopes of the carbon, in which you have to go for making a difference between graphite and diamond. So we are knowing about the arrangement of that particular, that is plain sheets like a structure when we talk about graphite, and diamond is having the tetrahedral structure. Okay, your this one, graphite is sp2 hybridized, wherein your diamond is sp3 hybridized. Other points are given over here. Next classification, if we talk, that is the ionic solids. Ionic solids are going to have constituent particles as the ions and electrostatic forces of attraction. Examples are given. Metallic solids, constituent particles are metals, and very usual to be said that the metallic bonds will be present among them. So this was the classification we have seen already. Next, dear student, very important, which starts over here, that is a crystal lattice and unit cell. Crystal lattice is the arrangement of the constituent particles in three dimensions, x-axis, y-axis and z-axis. Unit cell, the smaller repeating unit of the crystal. First, very important, is the primitive unit cell. It has a lattice point at each of the corner, as you are able to see the diagram. Centered one, if we talk about, we are having face-centered, body-centered and end-centered. Okay. Next, number of the constituent particles. Primitive is going to have one constituent particle. Reason behind it, 8 of the corners are having 1/8 part. 1/8 parts. So total, when we go for talking about the 8 parts over there, total 8 corners over there, we will be getting 1 constituent particles. Similarly, face-centered, 4. Okay. Body-centered is going to have 2, because 8 corners are contributing 1, and in the center you are having 1 constituent particles. End-centered, you are having half on both the sides, because only half will be participating, half is outside. Okay, so it is going to overall participate 2 constituent particles. Fine. The 7 crystal system, that is your CTOMHTT. That is what you have to remember. Okay, cubic, tetragonal, orthorhombic, monoclinic, hexagonal, trigonal and triclinic. Dear student, along with this, the sides and the angles are also given. Next, if we talk about the 14 brevis lattices, dear student, your P, that is primitive, BCC, that is body-centered, FC, that is face-centered, and EC, that is your end-centered. So which is showing which type of the lattice? I have given it over here, you can refer it well. Next, nearest neighbor distance, very important one. As we have observed, it is used in the numericals. It is the value used in the numericals. Simple cubic, that is your simple one, that is having the radius is equal to a by 2, that is a is equal to 2r. Okay, a जो आपका edge length है, that is equal to 2r. That is we are getting from the formula, which you can refer. Next, face centered. Dear student, face centered, we are taking the triangle ABC, and with the help of the Pythagoras theorem, you are having your AC square is equal to BC square plus AB square, and finally, by doing it, we are getting D is equal to under root 2 divided by 2 into A. So, can we go for writing the A from this? Yes, we can go for writing the value of the A from this particular, that is, or else you can say radius. So, we are getting the radius is equal to A divided by 2 into under root 2. How we have done it, you already know. Your A is equal to 2 under root 2R. Next. Next, we are going to have body-centered. So, body-centered, dear student, again we are taking the triangle, that is ABC. My dear student, you don't have to learn this, how we are arriving this, but yes, you have to remember the formulas very importantly. Okay. R is equal to under root 3 by 4A. That is what we got from the particular solving this structure which we are having. Fine. Next. Relationship, if we are going to talk about nearest neighbor distance. See dear students, simple cubic, face centered and body centered. What is diameter? That I have given. What is radius? That I have given. So this is a table you can remember. This is very important one which you have to remember, and you have to note down also, and you have to remember it also. Next, if we are going to talk about, we are going to talk about the what we can say, the relation of your D and R over here. That is what very important you need to understand. Relationship between the edge length and the radius of this sphere are in the unit cell. Face centered A is equal to 2 under root 2R. Body centered A is equal to 4 by under root 3 into R. Simple cubic, that is A is equal to 2R. So dear student, this is what we have seen earlier, and this is very important one. We are doing the quick revision. We'll be not going in more detail. We are just going with the revision. Close packing in crystal, one dimension, my dear student, your coordination number means your number which is touching the central atom is 2. Coordination number is 4 when you talk about the 2 dimensions. You are able to see we are having 2 type of a structure, square, close packing, which is having the one particular particle surrounded by the 4. एक particle को 4 particles touch कर रहे हैं. Fine. Okay. AB type, if we go for talking about hexagonal close packing, your coordination number will be 6. एक particle को 6 particles touch कर रहे हैं. Packing efficiency will be 60.4% and empty space will be 39.6%. That is what you have to remember. Okay. Next, if we talk about 3 dimensions. Now see, in this we are going to talk about x-axis, y-axis and z-axis. By square packing we are able to see again, this is the type of the arrangement known as simple cubic. Primitive unit cell, AAA type of the arrangement. And you are having the hexagonal close packing arrangement. So dear students, this arrangement we have already talked about, and you are able to see covering the tetrahedral voids. We are getting the coordination number as a 12. आपके एक पार्टिकल को 12 पार्टिकल्स टच कर रहे हैं. Packing efficiency 74% and number of constituent particles, that is 6. Covering octahedral voids. Octahedral voids when we are covering, dear student, it is your ABC type of the arrangement. and you are able to see that CCC is equal to FCC. Closed cubic pack is like a phased cubic pack. You are having A3B type of the arrangement. Your packing is 74%, coordination number 12.